I'm Dan Grabois, and welcome to my podcast. Today I'm going to be talking with Ankur Desai, who is a climate scientist, and we are talking all things climate. Ankur, good morning.
Good morning, Dan. It's a pleasure to chat with you today.
I'm so glad you could talk to me. I have so many questions, and I think lots of people have a lot of questions. First of all, I identified you as a climate scientist. Would you say that's accurate? I know you teach obviously at UW-Madison, as do I, in the Department of Atmospheric and Oceanic Sciences.
That's correct.
Correct?
Yep, that's correct. So
Do
yeah,
you? So, are you a climate scientist?
I will accept the label because I think climate scientist is a broad bucket, right? It includes people who are kind of doing the fundamentals of the physical climate system and writing the computer models and analyzing the output, all the way to the people who are thinking about what does this mean for people, for society, for ecosystems, and everything else, all the way to the people who think about how do we address this in policy and technology and all the solutions that have been proposed over the last period.
So, just to establish your cred, I think you went to Oberlin College, and then you must have gotten a PhD. Where did you do your PhD work?
Yeah, so I did my PhD at Penn State in meteorology. I did that because I actually started at Minnesota, where I did a master's degree in geography, which is kind of in many ways where climate studies had its origin as an academic study. Meteorology really came about more around World War II, particularly around weather forecasting. But then, as it became clear that weather and climate are two sides of the same coin, then that kind of merged into its own discipline. So I followed my advisor out from Minnesota to Penn State, and that's kind of where I got in to becoming a card-carrying meteorologist. And as much as people in my neighborhood want me to forecast the weather for them, I just point them to the National Weather Service or the professionals that we train in our department, um, live and breathe that stuff.
Okay. And how long have you been teaching at UW?
Yeah, this is my 18th year. So it's been fun. I keep tracks. We moved here when my wife was pregnant with our middle child a week or two before her due date, which she does remind me. And so I keep track based on however old she is. So she's 18.
Okay. Well, let's get into it. First of all, what is the climate? I
Yeah.
don't mean what is the today's climate. I mean, what does that mean, climate?
Yeah, there's been a couple of fun ways to describe this, but we'll just start with the simple definition, right? Climate is the average of weather over space and time over periods that average out kind of day-to-day fluctuations that are kind of the random nature of weather systems that come and go. And over large enough spatial scales that it's not about kind of what's happening in your backyard, but over kind of some region where they might have similar processes affecting it. I kind of like to use when I talk about climate change with the public. There's a couple of nice quotes that people have dug up. One I like is climate is what you expect and weather is what you get, right? And so if you think about temperature and precipitation and cloud cover and snowfall, these are all things that vary from hour to hour with the weather. But if you were looking over, say, periods of years to decades, you'd start to see patterns, right? And most, I think, we're all familiar with some patterns, right? It's cold near the poles and it's hot near the equators and it's rainy in the rainforest and it's dry in the deserts, right? And those are the types of patterns that we call climate.
And what is climate change and what is global warming?
Yeah. So both terms have kind of popular meanings, but scientifically they are related to the same topic. So climate change is the broader umbrella that includes all the ways that the climate, right? So this average we kind of view has some stability, but over time periods where you have something forcing it, like say the change in the strength of the sun or a change in how many volcanoes are spewing out, or as we know, a change in fossil fuel emissions, that mean state can change with time. And so that's climate change. And climate change has always happened, right? It happens naturally because of things like impacts from Earth's orbit and our solar system and the cycle of ice ages and all those things, and then by humans as well. through the emissions of greenhouse gases and land use change. So global warming refers specifically to the period over the last century since the start of the Industrial Revolution, where the accelerated use of fossil fuel-based emissions of oil, coal, and natural gas, along with large-scale deforestation, has led to an increase in and carbon dioxide, methane, and other greenhouse gases in the atmosphere. And that leads to a change in the global average temperature, which then feeds back into the changes in weather patterns that we are all experiencing today and are likely to continue and potentially accelerate into the future.
So greenhouse gases, I remember going
Yeah.
with my mom into a greenhouse to buy plants, and I know it has sort of frosty windows and it gets warm and humid in there even if it's cold outside. So is greenhouse gas, are we talking sort of a metaphor to that where it's a warmer space when the greenhouse gas is serving as the sort of frosty glass, or what do we mean by greenhouse gases?
Kind of. So it's kind of fun. So when I teach, I have an undergraduate climate class we teach. We actually listen to this 60s era record album of science songs, and there's a great song called "What Does the Glass of a Greenhouse Do?" And then it goes deep into trying to connect that to the atmosphere. And the thing about it is that is actually technically wrong. And so, as much as that term makes has a nice colloquial feel to it, what a greenhouse does for kind of keeping plants warm is primarily by blocking exchange of air with the outside, right? And then allowing all that sunlight to filter through and to heat up the room and not cool off because the wind is pushing all that warm air away. Greenhouse gases are a little different in that, the air is made up of mostly nitrogen and oxygen, right, that we breathe. But a small proportion of that is made up of like 0.03% is carbon dioxide, 0.04%, and then smaller quantities of things like methane, which occurs in parts per million, single parts per million type quantities. But each one of these has a unique impact in that, like all gases, right, can interact with light, and not just sunlight, but the kinds of light that you can't see, like infrared radiation or ultraviolet or X-rays, right? Those are all different types of light. And so the Earth, right, absorbs and gets all of its energy from the sun, which is mostly visible light. And then that heats up the ground, and the air itself doesn't actually absorb a lot of visible light. And we know this because I can look out the window and see the sun, right? Uh, and as the ground heats up, then things that are roughly Earth temperature, like trees and soils, and including you and I, we mostly emit infrared radiation and we reflect sunlight. So we reflect some of that sunlight back to space. And we know that because we can see the Earth from space, from like the space station. But the remainder of that sunlight energy is being used to emit infrared radiation, right? And that is being emitted back to space. And we can actually do this. Astronomers use that infrared radiation emitted back to space as they see in their telescopes to kind of infer what the temperature and atmosphere of other planets are like. So the same thing is true in Earth. And so what happens in the atmosphere is oxygen and nitrogen don't really react too much with infrared radiation, but carbon dioxide, methane, and the several other greenhouse gases and water vapor all strongly absorb infrared radiation. And as a result, they heat up. And if they heat up, they also, because their Earth temperature, emit infrared radiation. And some of that goes back to Earth. Well, the stuff on the ground absorbs now sunlight from the sun and this enhanced infrared radiation from the air. And so then it warms up even more because if you have more energy, you get hotter. And then that then leads to more infrared radiation being emitted to the air, and then the air gets warmer, and it kind of is this feedback loop back and forth until you reach some equilibrium. And that is kind of the planetary temperature you would expect with an atmosphere. And so the best analogy I like to think about it is something almost like a blanket, right? Like you individually generate heat, and if you want to stay warm in your bed at night, what do? You throw in a blanket, and if you're still cold, you might throw in another blanket. And what's that blanket is doing is insulating that heat that you're emitting.
So the
And
blanket doesn't actually warm you, you warm you, and the
yes,
the heat that your body puts out is conserved by the blanket.
Exactly, right.
Okay.
And so it's a similar idea, right? And so there's lots and lots of subtleties to this and how this works, but it is fundamental physics that is mostly built on theories from the late 19th centuries and was really put together for how this works in the atmosphere in the 1950s and 60s. That led to the Nobel Prize in Physics in 2021 for the work by Suki Manabe, who kind of developed the very first model of Earth climate.
Okay, well, I'm going to want to get into how we study this, how we study the change in this. But before we do that, I want to look at the fact that we hear from certain political spheres that
Yeah.
talk of change in the climate is not true. It's a hoax. And I think if we can first just like look at where one might say any of this is false,
Mhm.
I think it'd be helpful to then, once we have that behind us or at least in view, let's go on to talk about how we study these things and then talk about what's actually going on and the prognosis for the
Yeah,
future.
absolutely. And
So, talking hoaxes generally, and let me start with one,
mhm.
and I'm sure then that will lead to many others. So, scientists like you are funded, obviously, in your research, and that research cannot get funded unless you agree with theories of climate change. Go.
Yeah, so that's broadly, I think, as a scientist, right? We all kind of wish it was a hoax, right? Like we're really interested in trying to understand this system. And in many ways, right? So this idea that, climate scientists are, a really big community, right? There's thousands and thousands of people, like I mentioned earlier, who study climate in all different ways. And the reality is, we're all actually looking for an angle to say, how does this system work in a way we don't think we know? And the whole game of science is not to have like, here's my one pet theory that's going to disprove the whole world, right? It's really about coming up with evidence from multiple lines and multiple studies in independent ways. And the fact that they're all converging on the same answer is not because of some grand conspiracy theory or some grand strong incentive that if I don't hew a party line, I'm not going to get funded. In fact, the most exciting ideas come from falsifying hypotheses. And as peer reviewers, I'm very interested in trying to support science that challenges the conventional wisdom. But the reality is that every time we've tried it, and there's been thousands of studies. Our goal as scientists is to falsify hypotheses, right? Our goal is to really say, okay, well, is it the sun? Well, a little bit, but not really. Is it volcanoes? A little bit, but not really. Is it fossil fuels? It sure seems that way. Does it seem like it worked this way in the past? That's what paleoclimatists do it. Does it seem like the computer models that are based on our physics theories from the 19th century and 20th century align? And it does seem to be the case, right? So it's really about this building consensus. The way to think about it is, um, I think we're all very sensitive to studies about personal health, right? Drink more coffee, drink less coffee, have more wine, have less wine, right? And it seems really confusing. And sometimes we think there's maybe even a push for a certain outcome to occur. And then we shouldn't discount the fact that there are bad actors, there is fraud in science, there is um, money involved in this, and that those things have to be carefully thought about. But part of the reason we have things like peer review, that we have things like, public discussions, that we talk here even, is to make sure we're being honest about all this, because that is fundamentally what drives science. But the same thing with like your personal health, right? Like it's not one, if one study tells you that drinking an extra glass of wine a day is good for your heart, you should take that with a grain of salt, right? Because until that gets replicated in independent studies in independent ways, and there's a consensus of evidence. And say one study comes out and says, well, if with these 10 people I looked at, it didn't work. Well, that also doesn't mean you throw out the thousand other studies that came before it. It says, okay, well, was that by random chance? Or is there something unique about that study that all the thousands of studies that came before missed? And once in a while, that's true. But the vast majority of time, until we have a preponderance of evidence, which is what we're doing in climate science, right? It's not just one thing that tells us that the climate is warming because of fossil fuel emissions and that this is harmful for society. It's a preponderance of thousands of studies by thousands of scientists in every country of the world, looking at this in their own way, primarily because we are just really curious and love to study this planet.
All right, here's another. Let's tackle that British paper from 30 years ago or so. Can you just talk about that paper? I can't even remember what it was called, and how the notes in the margin said, here's where we do the trick.
Right, right.
That's often held up as an example of the
Right.
nefarious nature of these researchers colluding with each other.
Yes, and in many ways yeah, that's been long discredited as primarily colloquial language used, right? I think the word trick is used quite a bit in computer coding and others, as in a clever mathematical way to solve a problem, right? And that is what was demonstrated to be the case. Further, there have been multiple other groups that have reanalyzed the data, including people who were questioning the science and have come to the same conclusion that was originally premised, right? Which is that tree ring data also confirm that the climate is changing.
Okay, good. And I got one more for you, and maybe you have
Oh yeah,
some ones as well.
for sure.
So I'm in Wisconsin. You're not here in Wisconsin right now, but you live here. I don't know how long you've been away. I don't think it's that long. So
Just a
you
few
lived
days.
through the last month, and it was cold here. How could there be
Yeah.
climate change? It was freezing cold. We spent weeks below zero. So this is obviously a load of bunkum.
Right. This one is hard, right? Because of course winter does happen, right? And even in a warm climate, we can still have extreme weather happen. It just happens less frequently. And it's really about probability. And the way to think about it is like, I can roll the dice, right? And let's say I have a single die, 1 through 6. And let's say 1 means cold and 6 means a hot day. We roll it, and it's going to be random. On an average, it's going to kind of settle on some average between the two, right? But let's say I did something to it. I loaded the die, so it kind of rolled more on sixes than on ones. And then I kept rolling it. Well, sure. Are you going to never ever get a one? No, that's not the case. That's not how a loaded die works. And it's the same way that climate system works, right? Weather is driven by all the processes that bring in warm and cold air and a clash of fronts. And in any one season, you might have a pattern set up in any one location that promotes a colder winter or warmer winter. It's just that the colder winter happens less often because global warming, which is increasing the global average temperature, makes it less likely that those cold air outbreaks will happen in the way they do. And so, and then the other thing to think about is if you actually I just looked at the percentiles of temperature differences from average over the last month over the whole globe. And not surprisingly, almost everywhere in the world has been very warm this winter, except parts of the Northeast US and parts of the Midwestern US, right? And in any
Our
one
bad
region,
luck.
always an outlier or two. But when you look at the globe as a whole, those are the minority. Another way to look at this, in the US, there was a study that looked at the ratio of record highs to record lows, right? And you would imagine in anyone's weather station, you would get roughly the same amount, right? Yeah, you have some hot summers, you set some record highs, you have some cold winters. But what's happened is that if you actually look at that ratio, we now set 2 or 3 record highs per every record low, right? So we still have record lows. They just happen half as often as record highs get set.
And if somebody were to say, yeah, but you're looking at the 50 years,
Yeah,
that's
yeah.
not enough range, what would you say to
Well,
that?
this is a good point too, but we can look first of all, we have multiple ways to look back in time, right? Our weather station record goes back to the late 19th century, but there's also some records that go back to the 15th and 16th century. And then we can couple that with other cool records, like the record of, for example, freezing and thawing of rivers and lakes, some of which go back to the 1100s, 1200s in Japan and in Europe, where you can clearly see this uptick that occurs soon after the Industrial Revolution. It accelerates after the 1950s with the rapid growth in population and fossil fuel use to support that world. So again, it goes back to this idea is it's not about one thing, right? Yeah, maybe some of our thermometers are wrong and we should fix those. But then you look at the lake ice, then you look at the tree rings, then you look at fossil caves, then you look at ocean sediments, and they all point to exactly the same story. And then you test them against theory and you say, can we explain it by the sun? Can we explain it by volcanoes? Can we explain it by fossil fuels? Can we explain it by land use change? And the only thing we know after looking at this for 50 plus years in that theoretical framework is fossil fuels. There is no other explanation that works. Until somebody has one, that's what we go on.
Okay, I got one more that I
Go
got
for
while
it.
you were talking. You guys talked about global warming, and then you completely changed it, and you said, no, it's not global warming, it's climate change. How can we trust you? You're a bunch of slippery people with no credibility. Go.
Yes. Yeah. Some of this is our challenge as scientists to communicate well, especially in an information environment that is strongly mediated by media interests that want to have a certain angle on a story and a strong desire to kind of have a two sides to every story, even when one side has the stronger evidence. So I think some of this is our fault. I agree. We tried early to use language when we're explaining this to the public, right? That we thought would best explain the science. And it's very hard to come up with sound bites with one sentence terminology to explain this really complicated system. So if you go back to the literature, the actual peer-reviewed scientific literature, there's no like, people are pretty clear on what the terms are, and we focus on numbers and the trends and the statistics and significance, right? But if I told you, oh, there's a statistically significant trend in the global average Earth temperature over 1950 to 1990, you would already have logged off of this call halfway through that sentence, right? And so we tend to use language that makes sense. This shift from global warming to climate change was to better explain some of the nuance of some of the things you were bringing up. Why is it in some winters you still have extreme cold? Why does a globally heating planet have different patterns when it comes to things like precipitation or other things we care about? And this is hard, right? Because nobody lives in global average temperature, right? You can't feel the global average temperature. What you feel is what's happening in your backyard. And the two things are linked, but they're not the same thing.
Okay, that's all good. Do you have any others you would like to debunk here?
Oh, there's so many. There's a really good website called Skeptical Science, and it has about 100 of the most commonly used arguments to sow doubt about climate science, and then kind of the literature and backing for all of these. I don't think I have a favorite. I mean, you brought up some of the very common ones about those. And I think it's important to realize that some of these things are actually manufactured, right? So there are interests, particularly in those who make money off of things like fossil fuels, right? And those who want to limit government regulation or are concerned about government overregulation, um, to want to sow doubt about the science. And this has been true for any controversial topic that has a large regulatory potential or impact, right? So whether that's things like the link between smoking and cancer, or the link between acid rain and the health of our lakes, or the link between the ozone hole and our use of chlorofluorocarbons in refrigerators and cars and everything else. And in all of those cases, right, the science was kind of progressing along its normal path and making very clear links. But because there were interests that had a lot to lose, there were concerted efforts, as we're still seeing today, on climate, to add in all these little whataboutisms, right? So even though the science is solid, if you put a little bit of doubt into somebody's mind, like, well, maybe there's this one thing that might be wrong.
Or what
Uh,
about my Uncle Harry who smoked
yeah,
2 packs a day and lived to 98?
exactly, right? And of course, genetics has a factor in this, right? But what we know is that most people who did that got, had worse outcomes, right? And that That's the kind of thing that's been happening. Naomi Oreskes is a historian of science, has a lovely book called Merchants of Doubt, and also was turned into a PBS documentary a while ago. And it kind of links all of those stories that I was just telling. And often it's the same actors, the same think tanks, and others that are kind of using the same playbook, primarily from an anti-regulatory stance. And I don't say that's the whole story. There's, of course, pieces of that that might be, there's similar things happening on the extremism and alarmist side as well, but not quite as well organized as we see on the selling doubt side.
But you don't, in your opinion, what we're not looking at is a bunch of rabid lefties who are studying this field to try to take down evil corporations, that sort of storyline.
Yeah, I don't doubt there are some of those that exist, but among the scientific community, the people really thinking about how does the science, what is this, what are the observations telling us? How does that fit our theories? And how do we use that to make recommendations about what will happen if we do X, right? The boundary of where we go into science is saying, this is what we know, and this is what we understand if humans make decision A versus decision B. And it's up to policymakers and regulators and the public who vote for them to determine what is the path they want to go down.
And I've often heard that the fact that some super high percentage of scientists agree on this interpretation of the data is clear evidence of collusion, but I think that most scientists agree on the theory of evolution, which
Right.
doesn't mean automatically that it's false and the product of scientific collusion. So, can you talk about that a little bit?
Exactly. I mean, it is fair to say that in all human endeavors, we sometimes have herding behavior around ideas, and that the way that ideas often evolve is when you do have groups of people kind of questioning the paradigm or the mainstream, right? This is the foundations of the philosophy of science, and like Thomas Kuhn's The Structure of Scientific Revolutions, right? And that does happen, right? But that is still requires kind of a preponderance of evidence. It requires a sea change across a large number of individuals who are saying, "Hey, hold up, we have something that doesn't fit your theories quite as well." And then it takes time to evolve. And that's a natural process in science, and it is something we have to guard against. But the idea that going back to this idea that there is no good theory after spending a century plus trying to find an alternative theory kind of leads people to be like, yeah, this is good. Let's move on to the next step. We understand how climate changes. We know how to simulate that computationally. Yes, there's lots of little subtleties that we're still working on and fun, and there's some really cool things going on with the ocean and sea ice and with forests and all sorts of things that, still require more study. But from a question of like, is the climate changing from fossil fuel emissions? And is that climate change detectable? Yes. Is it having an impact on weather extremes, on flooding, on sea level, on ecosystem health? The answer is yes. There's really no doubt about those because it's been studied for so long. The questions of how do we address this and what are the right ways and what are the costs and benefits to society, those are debatable questions. And my preference is that we move to primarily focusing on that. What do we do about this? What is our acceptable level of risk? What are we willing to invest in now to make sure our children and their grandchildren and their grandchildren have a safe and comfortable climate in which they can live and proceed to continue to do the things that we all value and care about?
Okay, so we will get to that.
Yeah.
Um, I have a sort of a general and a specific question, which is, and you've alluded to how this is studied, but can you give kind of an overview of how people in your field study this, just generally? And then, how do you in particular study this in your own research?
Yeah, so broadly, right? So I mentioned I'm currently actually department chair of Atmospheric and Oceanic Sciences here at University of Wisconsin. So I actually spend a lot of time reviewing what my colleagues are doing as part of our annual evaluations and of course promotion processes and everything else. And one of the things that I love about our field is that we all kind of go about these in kind of unique ways that represent different ways of approaching to science, right? So there's a part of climate science that's very much driven on trying to diagnose how climate varies by running these very high resolution, computationally expensive computer models on supercomputers. That requires a lot of collaboration with national centers like the National Center for Atmospheric Research or colleagues at NOAA or the Department of Energy, who have the computational resources. And they make experiments in these computer models where they can say, what happens if we do X? Or what happens if we simulate this process in a slightly different way? Because we're trying to understand, say, how clouds work. We're trying to understand how El Nino works or something like that and how that might change. And so that's kind of involves a lot of people, and some of those people are oceanographers, and some of those people are glaciologists, and some of those people are atmospheric scientists, right? And some of those people are like me, who focus primarily on ecosystems on land. Then there's a whole another side of climate that really focuses on how can we make really good observations of climate, both of the past and of the present, to really say how good are our models and can we discover something about how systems respond, right? And so paleoclimatologists primarily try to build what we call proxies or records of the past using things we know vary with climate, like snowfall accumulation in Antarctica and Greenland that piles up year after year over hundreds of thousands of years. And the thickness of those records and the isotopic signature of the snow, its crystals themselves, tell us something about how warm or how wet or dry the world was, and how much CO2 based on the air trapped in the bubbles between them.
So would that be
Or
like looking at ice cores and that sort of
Yep.
thing that we've
Ice
maybe heard of?
cores that are multiple miles deep, which is pretty amazing, allow us to go back a million years in climate. And that requires a lot of people. Everyone from knowing the actual engineering of how do you build a drill and extract ice that deep in a way that doesn't actually melt the ice and all that, along with the very careful work of extracting all of that data from each little section. And then people who look at trees and tree rings. My work is mostly focused on trying to understand how what's on the land, the biological organisms, particularly plants, influence climate and how they're influenced by climate change, particularly things like rising CO2 concentrations, warmer, longer growing seasons, droughts and changes in drought frequency, or the impact of invasive pests and things like that. And the way we do that is we make long-term observations in different ecosystems around the world. So I run a set of sites in northern Wisconsin and Michigan where we build towers. These towers can be 100 or 200 feet tall, but we put them so that we can sample above the forest. And I directly measure things like carbon dioxide and methane and how that stuff is transported in and out of the forest, from which I can do things like estimate how much photosynthesis does this forest as a whole do, and how does that change under different weather conditions or climate conditions. And then I combine that data with people around the world doing similar measurements, and we share this openly and freely. Dan, you can go and download this data yourself and make your own graphs.
I'll be
Um,
doing that in the next
yeah,
hour.
that's right. We've even built an AI bot with my colleagues at DOE, so you can just do this in plain language. Um, and and then we get to see how the whole world is responding. What's happening in the deserts of the southwestern United States? What's happening in the tropical rainforest in the Amazon? What's happening in the monsoon-driven savannas of India and Southeast Asia? What's happening in the tropical peatlands of Borneo? And then by putting all those pieces together, we start to see what we call the breathing of the biosphere, right? The biosphere takes up CO2, it emits CO2, it emits methane. All of those change greenhouse gases subtly, right? And that has some impact. So, for example, about half of the fossil fuels that we emit to the atmosphere every year, the carbon dioxide, gets taken up by plants and the ocean through biological processes. And that's a pretty large subsidy, right? It buys us time in terms of the emissions. If we didn't have that happening, right, global warming would be happening at roughly twice the rate. And what we really, really need to know is that going to continue in the future? And are there clever things we can do, like protecting forests or practicing, experimenting with forest management techniques or restoring wetlands that can actually maybe even enhance that uptake and therefore slow the rate of greenhouse gas accumulation even if we didn't cut back on fossil fuels.
I'm glad to hear that little ray of hope coming through there at the end. Um, let's see if you can make a number assignment where 0 equals the Garden of Eden
Okay.
pre-eating of the apple. Everything is pristine and perfect. and 100 will be unfit for human habitation.
Right.
Where do we stand now?
Yeah. I mean, it depends on how you look at it, but I would say,
Classic academic answer.
it's right. It depends is a good answer, right? It's always the right answer. Yeah, it's hard to put a number. There are these kind of planetary assessments, health assessments that get put out, this idea of tipping points or, and we think about biodiversity and extinction crises and how that supports humanity. We think about climate change. We think about sea level rise. We think about even all the other things that impact humanity, like global conflict, right? Which is also exacerbated by changing food availability and food security and things like that. I would say we're at a pretty precarious point, right? Probably in a halfway point, right? Where like we can live, the earth will continue. Humans seem to be muddling along, but a lot of people aren't doing great. Um, it's a real question of, and often what I point out to is, we look at all these climate change charts, and sometimes you hear this quote like, "Oh, we only have 10 years to fix climate change," and that's not entirely true. But what that is hinting at is that if you look at all the climate simulations, the decisions we make about fossil fuel emissions in the next decade or so have enormous consequences on whether we're more on that 100 side of your scale or kind of staying as is side of your scale, maybe even getting slightly better. Because we're right at a point where we're starting to see climate warming accelerate slightly. We're starting to see fossil fuel emissions from the legacy of fossil fuel emissions over the last century really having their impact because CO2 stays in the air for almost a century and the oceans absorb most of the heat initially, and the oceans take a while to heat up, right? And so all of this stuff is now really coming to fore. This doesn't mean we're screwed. It means that decisions we make in the near future are very consequential for how the world looks like in 40 to 50 years from now.
So if someone sees an article in the paper that talks about this 10-year window that we're in, it sounds like we should read that more like the decisions in these 10 years are what is crucial and not we can change everything and then we'll be fine if we just stop driving cars and using gas
Right.
stoves and whatever it is over 10 years. That's not, no one's talking
No,
about
right.
that stuff.
That's not realistic and it's not a healthy perspective either, right? Because I do think when people get overwhelmed, right? We've even talked about this concept of climate anxiety or climate grief. We see this a lot in young people in particular, right? There's people saying, I mean, my own kids sometimes will say, I don't want to have kids because of climate change, right? Like, and that's a common sentiment. And I think that's actually somewhat defeatist of an attitude, right? Because it really kind of just says, we're done, we're going home. I don't want to deal with this. And that's a very common response when we're overwhelmed by anything, right? I'm overwhelmed by my email inbox, and my first response is, I'm not going to answer any of these. And what I really need to do, right, is be like, okay, which ones can I tackle now? What are important to prioritize now? What are the emails that can wait? What are the ones that, I can apologize later for, right? And the same kinds of things kind of occur when it says, all right, we know some things about climate change are consequential. Um, we should try to reduce emissions to prevent the worst case scenarios, but we should also accept that we need fossil fuels in the short run. They're very amazing things, right, that power the world. And we like powering the world, and there's an increasing demand for powering the world and things like data centers and everything else. We should solve that problem too, and we should be able to adapt systems to be able to deal with some of the consequences that we're seeing already from extreme weather, from sea level rise, from flooding, from changing crop yields and everything else.
So I suppose there is change that can happen at a kind of international level, change can happen at a national, governmental, legislative level, state level, city level, but also at the individual level. So let's reverse that. Let's talk about what can I do? Like, should I get rid of my gas stove and buy an induction stove? Should I actually have a car that's a plug-in hybrid. So am I doing something good, or is that just did I just
Right.
throw my money away on a toy? Walking to work, I assume, is better than driving my car. I think probably everyone would agree with that. But what can I do? What should I be doing, and still lead a nice lifestyle?
Yeah, it's a very great question. And it is probably the most commonly asked question. In fact, it's the title of the Badger talks that I give to the public around the state. What can you do about climate change, right? And my kind of, you know, cute answer to that is not a lot, but what can we do about climate change is a lot, right? And that really this is a collective action problem. And yes, the choices you make are going to be very personal to you, right? About your lifestyle and your needs, right? Whether or not, for example, changing commuting habits or changing diets or changing energy use or energy efficiency has a is something that you can afford to do, is something that you want to do, and is something you have the capacity to do, right? And those things are going to be very individual. And while those are all useful things to do and think about, and I think it's worthwhile for all of us to like care about the world we live in and the world environment around us and to make choose actions that, minimize harm. The most important thing we can do is really work together with other people. Like one of the things we see in surveys done about climate change is the vast majority of Americans, regardless of political affiliation, believe climate change is happening, care about climate change, think it's going to be harmful to some people somewhere, even if it's not them, but believe that their neighbors don't think the same as they do, right? And so we tend to think that most people, it's kind of this divisive topic that's 50-50 or something like that. And that's actually not the case. It is 50-50 maybe on like, if you go around a very specific thing about, should we ban, I don't know, internal combustion engine or something like that, right? But if you're talking about should we do something about this, and then you ask those same people, should we have sensible regulations, policies, even carbon taxes, there tends to be majority level support around most of those. But then you ask them, do you talk to your neighbors about climate change as a topic ever? And the vast majority of people will say no, right? And that kind of leads to this mismatch between can we do something about this, and does anyone else want to do anything about this? And the reality is that there is a lot of energy around this, and I see it, of course, most strongly in the folks we teach in the university who are younger, who have been, understand the science and know that this isn't affecting them in their lifetime more than even you and I. Um, but there is a sense that like what we really need to do is right, talk about it, make it an issue, ask the people we're voting for like where their stands are on this. Um, Make groups accountable, right? Support the nonprofits or the charities that we care about that are doing work on the ground to help us protect society and nature from climate change impacts. Um, those are the things that we should do.
So I'm pulling out of what you're saying a really challenging gap.
Yeah.
And the gap is that my driving a plug in hybrid is, in a sense, a performative act. I'm not saving the planet. I'm feeling good about myself. But the difference between getting an average of 45 miles per gallon and 25 miles per gallon is not going to have a huge impact on the world. And yet, if we all drove hybrids, it wouldn't it would be a collective action. Just like my vote for senator from Wisconsin is doesn't carry a lot of weight. I think a lot of people go from there to say, I'll drive an old gas guzzling car because it's comfortable, and I won't bother to go vote because I
Mhm.
want to go to the movies instead. And how do we bridge the gap between our own personal performative act and then seeing that it is a piece of the whole and somehow unifying so that we can all act together?
Right. And some of this is about tying it to your values and trying to understand where your community is at on something, right? Some of the best actions I've seen have been like, hey, I have been thinking a lot and reading about solar, and I'm going to bring this, say, to my faith community and say, hey, this is a way we can save a lot of money, right? And we can use that money for other things that we care about in this community, and it provides and it shows that we care about the environment, right? And so even though it's a little bit performative, it actually has that kind of collective response, right? There are places and ways in the same way that like, yeah, we can sometimes feel very defeatist about whether our vote counts or not, right? And one option is to just tune out of the system, but the other option, right, is to get involved, right? To canvass people, to think about the issues, to support political activities that allow more people to be informed. And there's a kind of something similar. If you care about this topic, right, the most useful thing you can do is find where the wins are, whether that's in your local community, right? And I wouldn't say like your choice is performative because sometimes change happens from kind of that critical mass, right? So I've seen, for example, if you drive around the country, you'll see right, rooftop solar showing popping up in places. But one of the things you'll notice is that it tends to be pretty clustered, right? So it's kind of like one house gets rooftop solar, and you're talking to your neighbor, and you're like, check out how low my electric bill has gotten. And hey, I got a person you should talk to. Because of course some of that is just that resistance, like I don't even know where to start, right? And then they connect it, and then they suddenly there's two houses, and then maybe you end up giving a presentation, end up saying, hey, the local neighborhood association is doing like a get together to talk about this, and then suddenly you have three more houses sign up, right? And then everyone starts to say, well, oh, everyone does this here. I guess I should do that, right? And so like those types of behavior change are real, and we've seen that happen time and again with other activities. For example, if we think about, increase in the rate of recycling of glass and aluminum, right? And how it was in many cases in the 80s that was when many of those programs were being rolled out in municipalities. It was children coming home from school talking about what they learned when their field trip to the landfill or whatever, right? And then next thing you know, you're sorting your recyclables because your kid is getting angry about you not doing that. And next thing you know, your neighbor sees that and they see that, right? And then it becomes an incentive, right, to want to do something together to make a real dent in supporting society. So I'm very optimistic about those levels of kind of bottom-up organization that I see around change. I think the challenge with climate is that some of the harms can feel like they're far in the future or they're far from your backyard, right? Like the biggest harms on climate change are not going to be in, you know, wealthy Western countries to primarily middle and upper middle class people, right? The folks who are vulnerable are the ones who don't have the capacity to adapt because of either, the ability to afford that, or because they're systematically excluded in some way from that. And, think about the history of air pollution and redlining of neighborhoods that led to minority communities primarily bearing the brunt of air quality impacts, right? And so there's kind of similar things happening with climate change, but it's global, right? And so, yes, what we're doing here may not have an immediate impact on, even Madison or Dane County, but it has potentially a meaningful impact on the health and lives of people in South Asia, right?
So it sounds like from what you're saying, you have a recognition that politically our country seems to ping pong back and forth between a
Mhm.
party in power that cares very much about climate change, believes in its hazards, and wants to address them, and is kind of frantic to try to think up government incentives to help. Versus another party will come in that doesn't believe it. It's a hoax. Live your life because we're rich and you must enjoy your life. But you're talking more about a personal level or
Mhm.
community level incentives. Is there some, can you think of other incentives or ways that an individual could build on this incentivizing process at the very local level?
Yeah, and I think some of this does tie into what you're just bringing up, which is that as all of that community level kind of thinking about what works for you and the people you live with and the people you care about and your neighbors also does have to bubble up at some level to the questions happening at national and international scale because greenhouse gases are well mixed around the globe and climate change is occurring everywhere, right? The only way that we're going to collectively solve this problem, right, is really to think about large scale fossil fuel reduction emission reductions everywhere, right? And some of that does require kind of getting individuals to think about where can they help with that. It's not just how you vote, right? Because yeah, there are political back and forth, but it's also about how we put structures in place, right? So the fact that the Supreme Court, a decade ago declared that greenhouse gases do endanger humanity, right? And that therefore can be regulated under the Clean Air Act, right? Which is currently in litigation, right? Um, is was a powerful thing that kind of, at least until last week, has mostly withstood political back and forth. It kind of changes the window of what we think is acceptable, that greenhouse gases are also air pollution, just like ozone and particulates, right? And that changing that conversation, we'll see what happens next with the current administration, but that kind of has become the accepted standard, right? And so now, by having that conversation, by having public comments to regulatory decisions, by having legal cases that go through from groups, from nonprofits, from youth groups, from elsewhere, we've seen this, for example, in Hawaii, with a group of young people who have sued the state to say that they're reneging on their climate goals, and courts are agreeing with them, right? And so there are things happening at larger scale that do matter too. And sometimes it's about connecting to the organizations that, align with your values and interests and supporting what they're doing.
Here's another problem that you're talking is making me think about. And I'm sitting in my house.
Hmm.
It's nice and warm. I'm on a comfortable chair. I had a nice breakfast. I can go where I want to go. My life is pretty comfortable.
Right.
And all of those things have a fairly high cost climate wise.
Hmm.
And I can see people being concerned that they're being asked to live at a lower standard of living. Turn the temperature down. Don't replace that old whatever because that ratty dining room table still holds up your plates, and so you should keep that and not buy a new one, and whatever it is. And so, how do we cope with the fact that our comfort is potentially at stake if we're going to save the planet? Just to put it in as stark as possible terms.
Yeah. So look at an example from very different. Let's say you have a neighbor who derives a lot of joy from playing really loud music that you hate in their backyard, right? So they're getting supporting their comfort, their needs. It's their property. They have the right to do this. What would you do? But for you, this is, and say all of your neighbors are kind of like, we don't like this, right? And this is decreasing our happiness because this is noise and harm to our ears, right? Now, this is a somewhat contrived example, but what do you do, right? Well, you have a couple options, right? One is, should there be laws about this, right? Is there ordinances so that we are properly accounting for the harms we might be causing by our desires, right? Because we all have to live together in a society. Should there be fines, or should you have to have a permit, or do you have to pay for your right to be able to do something, right? Which then might change the incentive structures, right? That's kind of similar to how we think about the role of taxes in society. Um, or, do we do some education? We go knocking on the door and be like, hey, look, I really would love it if you didn't do this between these days and these hours. And we come to some set of community standards, right? We're seeing that a lot in the climate space around things like carbon credits and setting corporate standards for scope, tracking emissions and being able to report on those. And that just allows people to be honest, be like saying, hey, this is what we do, and this is what we're trying to do to reduce those, right? And um, so the climate side of that is very similar in that, yes, we all are very fortunate to live in this world where we can use fossil fuels relatively easily and cheaply. That doesn't come, but the actual infrastructure and work to make that happen, and then the pollution that occurs from that has a cost. It has a cost on lives. And a lot of interest right now is trying to be able to quantify that directly. What is the impact of climate change on lives lost? Or what is the impact of climate emissions reductions on lives saved or on dollars saved in terms of economic harm, right? And sometimes it's even about tying it to individual corporations or polluters or countries, right? And trying to be able to be like, this is your burden on society. What are you going to do about it? And that way, it's not so much about like, I think the idea of shaming people for like, oh, I love red meat or I love my snowmobile or whatever, right, is harmful, right? We want to be able to support the things we love to do as humans. We just have to figure out how do we live collectively as a society on a planet with finite resources so that everyone can thrive and prosper equally.
I think that's the perfect place to end.
Okay.
Thanks so much for talking to me.
Thanks, Dan. That was fun, and look forward to catching up in the future.
Okay.